Equivalence relations. Formation of an equivalence relation in children with autism using a transfer of stimulus function procedure. The researchers, Alexis Henry, Tiffany Thomas, Jomi Hiriata, and Bridget Joyner. Conducted in conjunction with Southern Illinois University, Carbondale. Formation of an equivalence relation in children with autism using a transfer of stimulus function procedure. The researchers, Alexis Henry, Tiffany Thomas, Jomi Hiriata, and Bridget Joyner.
In 2001, Stephen Hayes and his colleagues released Relational Frame Theory, a post-Skinnerian account of human language and cognition. They essentially refuted Skinner's definition of verbal behavior as non-functional and inapplicable outside of very specific contexts. Hayes and his colleagues instead pushed for a more functional and relational form of verbal behavior, and they created these constructs of frames that verbal behavior can fit in, where verbal behavior can interact and influence each other rather than being directed through one-way contingencies. Two phenomena that clearly demonstrate relational frame theory is equivalence and transformation of stimulus functions. Equivalence is training symmetry between three stimuli. One stimuli is trained to a second, and the same core stimuli is trained to a third. And spontaneously, the second and third stimuli are related equally without training or reinforcement. Transformation of stimulus functions is training relations based on its formal properties and transferring this function through contextual cues and creating conditional discrimination so that when it's presented to an arbitrary novel situation, the function can transfer to this new situation. Class mergers are when stimulus classes are linked together by training relations between them. In matching to sample, you would do that by including stimuli from one class as comparison stimuli for another class. The present study included class mergers and equivalence training as well as transformation of functions.
This study included 3 school-age boys diagnosed with autism and used a computerized RFT training module created through Visual Basic. A multiple baseline design was used to train good and bad using a color contextual cue. Phase 1 trained participants good and bad using non-arbitrary stimuli and its associated contextual cue, orange being good and green being bad. Phase 2 then trained 2 stimulus classes of words associated with good and bad, also using contextual cues, orange and green. In Phase 3, participants were asked to match an arbitrary word to a non-arbitrary stimuli given the contextual cues. Phase 4 demonstrated transitivity by requiring the participant to match the non-arbitrary stimuli given the contextual cue to the arbitrary word. In addition to the 4 phases, we collected baseline data and demonstrated transformation of function using a pre and post test where participants were asked to choose only the good pets. The pre and post test allowed us to directly compare results and determine if derived relations existed.
Now for the results. Data is presented here for visual inspection in the form of a multiple baseline design across subjects. The x-axis shows the total percentage of correct responses. The y-axis shows trial blocks according to the phases. Participants 1, 2, and 3 completed the first phase in only one trial block. There was an 80% criterion set for progression from phase to phase, and that was embedded within the VB program. All participants exceeded criterion for phases 1 and 4. Participants 1 and 2 exceeded criterion for phases 2 and 3. Participant 1 required the most phase 2 trials in order to progress to the next phase. Though there was some within phase variability, all participants' post-test performance remained above 70% across all post-test trial blocks. Nearly half of those were 80% or higher. Therefore, we can say with some assurance that the present study was successful. There was transference as well as transformation of stimulus function according to the data. The purpose of this graph is to display a transformation of stimulus function by comparing pre-test results with post-test results. If you look at the bar graph, you'll notice that participant 1 completed 3 pre-test trials at 0%, therefore displaying the most significant change in behavior or transformation of stimulus function. In contrast, participant 2 displayed no change, scoring at 70% selection for both the pretest and the post-test. This was partially due to an over-selection or preference for orange in the pretest. Although it can be noted that at 70% selection, it could have increased in the post-test.
The discussion. Some of the limitations of our study, the Visual Basics program was inflexible as far as making certain changes to the program. Um, the good color, which was orange, there was a contextual clue preference demonstrated in the pretest. Correct responses were not recorded for green and orange separately, and thus the data could not be analyzed as A1 to B1, A2 to B2, B1 to C1, or B2 to C2. The number 1 stands for the good, and number 2 indicates bad. Suggestions for future research, first would be a color preference assessment. A manually administered test may help depending on what type of program that you're trying to use. An increase in the subjects because on this project, as you've seen before, there were 3 participants. An increase in participants would yield more data. Possibly present a neutral distractor stimulus in the pre and post test to potentially reveal avoidance behavior. And also attain probe data to investigate the strength of the relation formed. Will it still exist in 1 week or 2 weeks or 3 weeks? That would be some of the suggestions that we came up with.